Okay, continuing on now, we're going to go ahead and start on problem 6. So number 6, we have x to the 4th is greater than 16. We're going to move the 16 to the other side so we have this equal to 0. So I have x to the 4th subtract 16 is greater than 0. And I'm going to factor this. So the square root of x to the 4th would be x squared, and the square root of 16 would be 4. So this is the difference of two squares. But then we also still have another difference of two squares because we have x squared subtract 4. So I'd have x subtract 2 times x plus 2 times x squared plus 4 is greater than 0. So then my zeros for this inequality is going to be 2, negative 2, and there's nothing I can put in here that's going to make that equal to 0. If I put negative 2 in there, it turns into a positive. So my only zeros are 2 and negative 2, so then I'm going to write it in intervals. So I'd have negative infinity to negative 2, negative 2 to 2, and then 2 to infinity. My numbers that are between them, I'd have negative 5, 0, and 5. And then I'm going to plug these numbers into this inequality and see if it's true or not. So we have negative 5 to the 4th power is greater than 16. So a negative times a negative times a negative times a negative is a positive, and this is going to be 625 is greater than 16. That's true. 0 to the 4th power is greater than 16. No. So that one's false. 5 to the 4th power is greater than 16. That's 625 again. And it is still true. So we'd have negative infinity to negative 2 unioned with 2 to infinity. I'm going to write that over here. So number 7, we have 2 times the sum of x squared plus 3 is greater than 3 times the difference squared of x subtract 2 subtract x squared. So first thing we're going to have to do is go ahead and multiply all that stuff out, combine like terms, and then move everything to the same side. So we're going to go ahead and start on that. I'm going to copy it down real quick. Okay, so the first thing I'm going to do is distribute over here. So 2x squared plus 6 is greater than, and right here I'm going to go ahead and multiply this out. So I'd have x squared subtract 4x plus 4. And then I'll have that 3 times that. So 3x squared subtract 12x plus 12 subtract x squared. And what I did right here, since it's x minus 2 squared, it's this. So FOILed it, x squared subtract 2x subtract 2x. Negative times negative is a positive. So that's how I got that. Then let's go ahead and combine these that are on the same side. So I'd have 2x squared plus 6 is greater than 2x squared subtract 12x plus 12. Start moving them across the inequality using inverse operations. So these are going to cancel. I'm going to add my 12x and subtract this 12. To get 12x subtract 6 is greater than 0. Then I'm going to factor out this 6 here. So I'd have 6 2x subtract 1 is greater than 0. I need to know what 2x subtract 1 equals 0 is, so I know what that 0 is here. So 2x equals 1 divided by 2. We have x equals 1/2. And that's going to be my only 0 for this equation. So my 0 is 1/2. Now I'm going to write out my intervals. So negative infinity to 1/2. And then 1/2 to positive infinity. I'm trying to figure out which one is going to make this inequality true. So let's go ahead. We'll use -1 and +1 to keep it easy. So 12 times -1 subtract 6 is greater than 0. That'd be -12 subtract 6, which would be -18. So -18 is not greater than 0. Then I'd have 12 times 1 here, subtract 6. So 6 is greater than 0, true. So my answer would be 1/2 to positive infinity. And I'm going to copy that down on this page. So we have 1/2 to positive infinity. Number 8, we have x plus 6 over x subtract 9 is greater than 0. So on this one, when I'm looking at my zeros, since it's already a 0 on this side of the inequality, I don't have to worry about it. So I just need what's going to make the bottom of this equation 0, what's going to make the top of it 0. So my zeros are 9 subtract 9 is 0. -6 plus 6 is 0. So then I break it into my intervals, so negative infinity to -6, -6 to 9, and 9 to infinity. My numbers, let's use -10, 0, and +10. And then I'm going to plug these numbers into that inequality. So -10 plus 6 over -10 subtract 9, which would be -4 over -19. A negative over a negative would be positive. And this would be greater than 0, so true. Then 0 plus 6 over 0 subtract 9, which would be 6 over -9. It's greater than 0. No, because it's negative, so false. 10 plus 6 over 10 subtract 9, which would be 16 over 1, is greater than 0. True. So my answer would be negative infinity to -6, unioned with 9 to infinity. Negative infinity to -6, unioned with 9 to infinity. Okay. Number 9, we have x plus 16 over x subtract 8 is greater than or equal to 1. On this one, we don't get to just say whatever makes the top of this equal to 0, whatever makes the bottom equal to 0, because this is 1 over here. I can go ahead and do the bottom though, because if there's a 0 over here on the bottom, it's undefined. So I know that 8 is definitely a 0. So then on the top, I'm going to have to solve this. So I'm going to multiply by x minus 8. So I'd have x plus 16 is greater than or equal to x subtract 8. Then when I go to combine my variables, I'd have 16 is greater than or equal to -8. And that's not true, so I don't have to worry about that. I just have to write out my intervals. So -infinity to 8 and 8 to infinity. So let's use negative. Let's use 0, and over here we'll use +10. So if we had 0 plus 16 over 0 subtract 8, it's equal to 1. So 16 divided by -8 would be -2. False. Then we'd have 10 plus 16 over 10 subtract 8. So we'd have 26 over 2. So 13 is greater than or equal to 1. True. So our answer would be 8 to infinity. And on this one, since it has the equal to, if it wasn't 8, we'd have an equal to. But since it is 8, it cannot equal 8. Otherwise, it'd be undefined. So the parentheses are still good on this one. Get down, so we have 8 to infinity. This last one's not so bad because they already have it factored for us. We just got to pull the zeros from it. And I'll go ahead and work this one on this page. So our zeros are 3, 6, and 7. Because 3 subtract 3 is 0, 6 subtract 6 is 0, 7 subtract 7 is 0. Now then we're going to write our intervals. So starting from the bottom, we have -infinity to 3, then 3 to 6, I want to space them out a little bit more. 3 to 6, 6 to 7, and 7 to infinity. So here let's use 0, 5, we have to use 6.5, and then here we'll use 10. Okay, so let's see. We'd have 0 subtract 3 times 0 subtract 6 times 0 subtract 7 is less than or equal to 0. So -3, -6, -7. Negative, negative, negative. The answer would be negative. A negative is less than 0, so this one is true. Here we have 5 subtract 3, 5 subtract 6, and 5 subtract 7. So 2 times -1 times -2, which would have been +2 times 2, which is 4. Here, 6.5 subtract 3, 6.5 subtract 6, 6.5 subtract 7. So 3.5 times 0.5 times -0.5. There's one negative, so this would have been negative, is less than or equal to 0, so this one would be true. Then here we have 10 subtract 3 times 10 subtract 6 times 10 subtract 7. 7 times 4 times 3 would all be positive, not less than 0, so false. But here's the kicker on this one. When you do it, it does have an equal to in it, and it can equal these because none of these numbers are going to make it undefined. It's just 0 there. And since we're looking for 0, if it's going to make it 0, it's obviously going to be 0. So we have -infinity to 3 bracket union with 6, 7 bracket. I was looking for the paper to write this on. 3 with a bracket, union with 6 to 7 with a bracket. So that is the last lesson on this chapter. I hope you all enjoyed it or survived it. Email me if you have any questions.